Okay, so we're going to pick up on 2.3 with biconditionals. So the bottom of the back page. All right, so first of all, a biconditional is when we combine a conditional and its converse. Okay, so conditional and its converse with the word and. All right, so we've got, for the conditional, we have if P, then Q. We're combining it, okay? So, and if Q, then P. So really what we're saying is P if and only if Q. And we denote that as, what's different about this PQ that you see here? It has two arrows, okay? It has an arrow going both directions. Okay, or you might see it this way, P-I-F-F-F. So P if and only if Q. All right. The reason that this is helpful with this biconditional, okay, is it says recall that a good definition is reversible. So it could be rewritten as a biconditional. Okay, those are reversible. All right, so let's try to put this into practice with, or let's look at this other theorem. We have the next theorem we have before we get there. So we have an equivalent disjunction theorem. Okay, and the equivalent disjunction theorem says the conditional P, if P then Q is logically equivalent to the disjunction. What is that disjunction? What are those symbols? Sorry, I'm trying to get that in, all to fit in there. What's the squiggly in front of the P? Not, okay. So it is equivalent to the disjunction not P. And then what's the symbol? Go back in some notes if you need to. Or is that a disjunction?
Wait, what was it called?
It was in the book. I was like, it's, I say, because you are right. It is the or and it is the disjunction.
Yay.
I say, we won't make you go back. Oh, okay, good. I was to say, I don't want you to take up too much time. But, so the equivalent disjunction, that's also helpful maybe, right? We should have looked there. And that's a disjunction. So the conditional P, if P then Q is logically equivalent to the disjunction not P, if not P, or Q. Okay, so let's complete the truth table showing that these are biconditionals. Okay, we're going to show that these are biconditionals. So let's see how we fill out the not P chart. So remember, we're going to compare the not P chart to the P. So if P is true, not P is false, false, true, true. Very nice. Okay, then we want to look at, let me change colors here, to get if P then Q. So we're going to look at both of these. They're both true, so it's true. Why is that one false? There's a false here, so this one's false. Why is that one true? Because the premise can be false. If the premise is false in P, then the whole thing is true. Good memory, Caden. Nice job. Okay. All right, hold on just a second. I'm going to erase what our focus is here. Okay. Because now we want to look at, we're looking at if, we're looking at not P or Q. So we want, whoops, I kind of circled over it. See if I can move that circle maybe. I can put my chart in a little better. Okay, so how about this next one? True, what do you think? So he says true. Do you guys agree with true for the first one? Okay, because it's an or, good. And then you said false because they're both F's. True and true because they're both. Okay, awesome. All right, so that's good because for here I wrote this note. For an or statement, it's true when at least one simple statement is true. So fantastic. Okay, whew. You guys are doing impressive work here. I'm amazed. Let me erase this. Okay, because now we're looking at if P, then Q, and not P or Q. So if and only if. Okay. Okay, so they're true, true. So this one's true. Can you see that orange?
Yep.
Okay. So then let's do the bottom two because they're both true. If true, then this is true. If this is true, this is true. Okay, so those are all true. How about the first one? If this one's if it's false, it's if and only if this is false, this is false. It's true too. What? So those are reversibles. You kind of just prove that they're reversible or that it's a good biconditional. So awesome job. Because that can be quite challenging to look at all the different components there. So very nice work. All right, so let's try example 5. Are there any questions? Okay, you guys breezed through that like way super easy, I feel like. All right, so example 5 is change the conjunctional to an equivalent disjunction. Okay, so we have if a child disobeys, then he will be corrected. All right, so first of all, let's break down a few things here. First up, it says change the conditional to an equivalent disjunction. So what does that mean, to an equivalent disjunction? Well, that is not. So we have to go back to what is a disjunction. Okay, so it's not P or Q, so we're gonna, which one is gonna be? Okay, so where did you like, where did we get, where you have a conditional, okay? We want to change it to an equivalent disjunction. So what is a disjunction?
If a child does not disobey, or he will be.
Okay, time out. What's a disjunction? Is it an
Disjunction is not P or Q.
Okay, where are you looking for disjunction? Like, where are you getting it's not P or Q?
Right there.
Okay, so you're saying for this one.
Yeah,
okay. Okay, I see. All right. Okay. I was like, where are you pulling this from? So, because I just want to make sure we understand, like everybody knows where you're getting it. So at the equivalent disjunction theorem that we looked at, he's saying it's not P or Q. So this is true. So we want it to be not P or Q. So now let's look at our statement. What is our P, our hypothesis? Okay, if a child disobeys is our P. Okay, so we have to not that. And so what's our Q part? Okay, he will be corrected is the Q. Okay, so I just want to make sure we understand. So that's why I'm breaking it down so much. Okay, so Caden said we have to make this a not P. We need to change that to a not P. So if If a child obeys, okay. Okay, so if a child obeys,
Or she will be corrected.
or, because we've got to get the not in there, so or he will be corrected. All right, that's it. You just can change it to the equivalent disjunction. If a child obeys, or he will be corrected. So really, do we need the if?
Child obeys or he'll be corrected.
Right, we can change it to a child obeys, because in this case we don't really need the if. A child obeys, or he will be corrected. Does that make sense? All right. So you guys did fantastic. So on your own, I want you to do those down there. Okay, write an if-then statement for A. Write it as an if-then statement, which we worked on Monday. And then write each statement related to the given conditional, and then determine whether the statement is true or false. Okay, so for your homework tonight, it's going to be 17 through 43 odd. Whoops, 17 through 43 odd. Around page 68, the same page we were on before on Monday, but we're going to finish up that 17 to 43 odd.